Hi, everyone, and welcome back to Lab 10. Today, we're going to be working on the Sheet 2 video. So I'm going to share my screen, and we'll go ahead and get started. So first things first, when you're open up SolidWorks, you can come in and open up a new assembly file. And just like last time, if you don't already have these parts downloaded, what you're going to have to do is come into our class portal and go ahead. Oh, not the bead breaker. You're going to go in here and download all of these SLD PRT files and make sure to put them somewhere on your computer where you can easily browse to them. Once you have them all in there, first part we're going to grab is the knee. The knee. And same exact process as last time. Go ahead and drop it kind of anywhere on the screen. And once it places, let's right click that part in the assembly tree, and then we're going to go ahead and float the part. Now, I'm not going to go ahead and turn on all my planes so we can see them. It's easy enough to just click on the front plane, hold control, click on the front plane of the main assembly, and go ahead and mate those together. Give it a second here. There we go. So we lock that in. Then we're going to go top plane of the main assembly to the top plane of the knee. Lock that in. And then right plane to right plane. And now we are set up. Our knee is not fixed. However, we're not able to move it around because we fully constrained it. Just like we fully constrained sketches, we can fully constrain a part using mates inside of an assembly. And with that, we can just go collapse the knee part, just so we can save some space over here, and insert components. And the next one that we're going to grab is the saddle. Go ahead and place that in. And the first mate we're going to do is a coincident mate. So we're going to grab it just like that. We're going to go ahead and grab it just like that. Mate. Some people call it a coincident mate. Some people call it coincident. I like coincident because what we're really doing here is we are creating it, so we are constraining it so that this face coincides with this face, the face on the bottom of the saddle here. So that's why I say it like that. Go ahead and click OK. Now, we need to center this on this, center this with the knee. So what we're going to do is keep with our mate toolbar open here. We're going to go right plane of the knee to the right plane of the saddle. And because they are drafted around the origin, then we can mate those planes together. And now we can see that this slot perfectly matches up here. If they're not drafted around the origin, you would have to, do a width mate or do some sort of, some math to figure out, where the center of this part is. But for our cases, it is drafted properly. Now, the next thing, we want to constrain this so that it doesn't slide off the edge here. So for this, we are going to use a width mate. And so we're going to go to our advanced mates, width. And instead of it being centered, I'll leave it centered for now, but I'll show you what the difference is. We can go centered or you can go free. Those are the two we're going to be using today. So for our width, we're going to use the front of the knee and the back of the knee. And for our tab, we'll use the front and back of the saddle. Just like that. It's going to center it just like it did before, but this time we're going to say free. Click the green check mark. And now you'll see that the saddle will slide along the knee and stop when it gets to the front or the back of that width mate. And there we go. So go ahead, you can click the green check mark or the X because we already have set those up. Now we've already locked them in. We're going to grab insert component again. And we're going to grab the table. And essentially just the exact same process that we just did. So we're going to make these coincident to each other, coincident to each other. Go ahead and grab that mate. Click the green check mark. Same thing before, we can mate plane to plane here. So if you don't already have the table, this can get a little hairy here because I know it's not quite as nice looking as you have it right here. And let's see if it'll let us, I won't let us go over there right now. So when you're in another menu, sometimes it'll let you pop over here and sometimes it won't. In this case, it's not allowing us to do that. So we have our assembly tree kind of popped off to the side here. So we can drill into our table and our saddle. And we are going to go right plane. Nope, I'm sorry, not the right plane. We're going to go front plane. Just like delete this. So if I already have a selection in here, you can just click on the selection and click delete. So we're going to mate the front plane of the saddle with the front plane of the table. Click the green check mark. And then we're going to go ahead and we can do our width mate. Same exact process as before. If you want to change the constraint to free beforehand, you can do that. That's just fine. And there's that. And then we're going to go the side and the side of the saddle. And we can go ahead and click the green check mark. And now, as you manipulate this, you can go side to side and front to back, and it will never pop off of the knee. Do a Control-7 to kind of reset our view here. And the next thing that we can grab is the bracket. So go ahead and insert a component, browse, and when that menu pops up, grab the bracket. And for this, let's go right on this face of the saddle and this face of the bracket. Mate those together coincident. Kind of bring this up a little bit. Now, this top, oops, delete that. So the top edge of the bracket might be a little difficult to grab here. Oh, there we go. And then hold Control and select this top edge right here. Looks like I grabbed it on the table. That's okay. Table and saddle. These two lines are collinear. So we're just going to make those coincident, just like that. And now we have to mate this so that it's centered properly. And how we do that is we can do a width mate, or we can go do a plane mate. In this case, I think it's probably better practice to do a width mate, but it really shouldn't matter as long as you know for a fact that that this saddle is drafted, at the center of the coordinate plane. So let's just go ahead. We're going to grab our mate. Wait for that to load for a moment. And then once it does, go into advanced width. And this will be centered. So our width is side of the saddle to the side of the saddle. And our tab is the side of the bracket to the side of the bracket. That'll center it perfectly. And we can go ahead and lock it in. Next thing we're going to do here, insert component. And we're going to grab the head. There we go. Now, unfortunately, these holes don't line up properly with the holes in the bottom of the head. So we're not going to use those to do concentric mate holes. We are concentric mates. What we're going to do is take the top of the bracket to the bottom of the bracket. Make sure that those are coincident. Then we have the front of the bracket to the front of the head, green check mark. And from here, we could do a width mate, or we could do a plane mate that's coincident. In this case, I think I like doing width mates. I use them a lot. And I just like that profile center. I use the profile center quite a bit in my professional drafting. So I think even though they are maybe a little bit more advanced than we would generally get to in this class, I think that they are, in terms of best practice, that's likely what you would be using in this situation. Because you want to keep the model as simple as possible. So if you end up leaving a company and somebody else comes in, they are able to like go into your model and everything really makes sense very easily. Everything makes sense very easily when they go in there. So you want to have the maximum number of constraints with the minimum number of individual features. Just like you want to have, just like when you're working with your sketches, you want everything to be fully constrained, fully defined. So that's all of these little tips and tricks that I'm teaching you really at the end of the day come down just to good drafting practice, good drafting standards. And with that, we have the head fully constrained the way we need it to be. Next, we're going to grab our pillar, our clamp, and our pin. So let's go ahead and do that. Just grab all three, open them. That way we don't have to keep going in and inserting components. So you can do that. I wouldn't get too ahead of yourself with it. So what's going to happen is it's going to load each one individually, and then it'll just kind of pop up on the screen, and you can place them, place them next to each other, place them near each other. And there we go. So we are going to first use the pillar, which is this little green piece, and do a concentric mate with this cylinder and this little slot here, this little hole. So we have the mate correct. However, in this instance, the alignment is off. So we can use that little trick I taught you in the last lecture. Just change the mate alignment just like that. Click the green check mark, and then go ahead and do a coincident mate just like that. Now, same deal with this little yellow guy, which is the clamp. Do a concentric mate. And we're actually just going to leave that just like that for now. We're not going to do, it's not fully defined. It can still kind of move all over the place. But let's just leave it just like that for now. If you come to the side, you can help you manipulate it a little bit more because everything's going to slide all over the place. So if you come kind of like right from the side, it'll be a little easier to manipulate it without everything being fully fixed or fully defined. So next thing I'd like you to do, you can rotate this first. To rotate this, you'd have to get out of your mate toolbar, and then underneath move, you can rotate and kind of rotate this the way you want it. That'll make it so, or that'll reduce the movement of everything when you go to mate. But in this case, I'm just gonna go ahead and mate that cylinder to that hole just like that. And actually, I didn't run into a problem there. That's excellent. So there are those three. And now I am actually going to go rotate. So I'm going to do a Control-1. And then I'm just going to kind of grab this guy and just rotate him real carefully. There we go. That's close enough. Because we're going to put a what's called the scale right in there. So let's insert components. Give it a sec. And we're going to grab the scale. And the first mate is going to be concentric. These two selections. Good stuff. And then you're going to do a concentric here. And now you'll see that these pieces that were not, these components that were kind of rotating all over the place are no longer moving, because now we have the dimension from, you know, this yellow piece and this orange piece to the table here are constrained because this head here is constraining the scale, which is concentric with this pin. So once we mated this scale to the head and to the pin, all of these other items now they're not fixed, but they are constrained within the context of the other parts in the assembly. It's just like in real life, if you have a rigid, if you have a rigid tube or a pipe and you have something else that's fixed over here, it's rotating all in space, then you put the tube through whatever that hole is, it's not going to be able to move anymore. So that's what we've done here. 2 more steps and then we're done with this guy. Is grab the clamp, the pillar, and the pin, highlight all 3 of those, and we are going to mirror them under linear component pattern. We're going to mirror those components across the right plane of the table. And it has to be the table, it can't be the main assembly, because the table is going to move back and forth. So the mirroring of these components, we want these to be constrained on this side as well. So as the table moves, that plane is going to move, and the mirror feature of those parts is going to remain consistent where we want it. So now, last thing we got to do is one final width mate with the scale. So we're going to go to our advanced mates, width, and the width selection is going to be the 2 ends of the scale. Oh, maybe. There we go. I was like scrolling through this. And then the tabs are going to be these outer faces of the pin. That is going to be centered. It's not going to be free. Getting an error here. Let's just see what happens. Add this mate and over define the assembly. Let's see. Interesting. Well, let's try it again. So width, centered. We're going to go there. We're going to go there. We're going to go here. And we're going to go here. I'm going to click OK. Oh, there we go. So that was maybe a little bit of a glitch. Sometimes you'll run into that. We tried it again and it worked. So I think that was a good example. Sometimes if something has to move really far over, depending on how the software is kind of looking at everything, or if it thinks that it might have to rotate something, it might throw an error. Go ahead and try it again and see what happens. Another way to do it, instead of just adding the mate and over defining, you can break other mates. And what will happen there is it will force that mate to solve in your view. And then there's another mate or other mates that will be like red or yellow. And then you can kind of go in and play around with them and figure them out, where the issue is. But so with that mate in place, now we have our operational mill. And nothing slides off the end. And everything stays where it should be. With that, go ahead and give me a Control-7, save it, and add this as your sheet 2 to the drawing file that we set up. So I'm just going to go ahead and save this. And that's it. I'll see you in Lab 10 Sheet 3.